Okay, welcome back guys. We're going to be solving the question 29 from the second chapter of Meriam textbook. And in this one, in order to insert the small cylindrical part into a closed fitting circular hole, the robot arm must exert a 90 Newton force P on the part parallel to the axis of the hole as shown, and we need to determine the components of force which the part exerts on the robot along axes. So in A part of the question, parallel and perpendicular to the arm AB, and in the B part of the question, parallel and perpendicular to the arm BC. So let's start with the A part of the question, where we have our axes parallel and perpendicular to AB. So let's just pull out our ruler. So let's do the parallel here, and this will be our perpendicular. Okay, let's call these two X and Y, and we're gonna call the other one N and T. So this is our X and this is our Y, and we have some angles that we need to figure out. So first of all, we know that this will be our horizontal line, and we know this angle here is 60 degrees from here, and if that's the case, this angle here would be 30 degrees. So it's easy enough to figure out this angle here, which would be simply 30 plus 15 or 45 degrees, and that angle is equal to this angle here, meaning this one is also 45 degrees. And now that we have this, it's easy enough to find the X and Y component of P. Let's call this one PX, and this one will be our PY. Now that we have the angle, it's easy enough to find PX and PY. So simply PX would be P times, since the angle is 45 degrees, the value of sine and cosine is the same. So depending on which angle you're considering, we'll get the same answer. It doesn't matter because it's in the middle. So if you want to go with this angle that I'm showing in here, PX would be sine of 45, and PY would be, since it's in the opposite direction, minus P times cosine of 45 degrees. And if we calculate this, we'll get 63.6 newtons, and for PY we'll get, again, the value is the same, 63.6 newton. It's just the way we called our X and Y, but the rest is the same. So that would be the answer for the first one. So basically the value of PX is equal to value of PY, which is 63.6 newton. That's the A part of the question. And in the B part, we have to go with parallel and perpendicular to the arm BC. So I'm just going to clean up the figure and we can see it better. It's a bit messy now. So for the B part this time, we will have parallel and perpendicular to BC. So let's call this one N and this one our T, just to get something different to what we have for the other one. So what we need to figure out in here is that we know this angle here, so we have this angle here, right angle. This part is 45, meaning this one is 45 too. And if that's 45, this part would be 45 minus 15, which is 30 degrees. And if that's 30 degrees, we have this angle right here, 30 degrees too. Again, we are going, we're using that principle. When we have two lines that are crossing each other, these two angles are the same, and as a result, these two are the same too. So we have the same thing in here. I'm gonna show it with maybe different color. So we have this line here and this line, and we figure out this part is 30 degrees, which means this part is 30 degrees too. And now that we have this, it's pretty easy to find the NNT component. Just gonna clean up. So if that's the case, this would be our Fn, and this would be our Ft. So a part of the question, let's find Pn first. As we can see, Pn would be simply P times cosine of 30 degrees, and Pt would be, since again it's in the opposite direction of our t, we'll have a negative sign, so P times this will be sine of 30 degrees. And if we calculate each of these, we're gonna get 77.9 newtons for Pn, and we're gonna get minus sine of 30 is 0.5, so basically 90 divided by 2, or 45 Newton, and that would be the answer for the second part of the question, where we needed to find the parallel and perpendicular components to the arm BC. So yeah, that would be all for this one. Please make sure to subscribe to the channel, like and comment, and let me know if you have any specific question regarding this one or the other 3 textbooks that we are covering in this channel. You guys take care, and I'll see you in the next video. Have a good one.